Today we're going to look at how to do surds in the most easiest way possible. Okay, we already have one on the board. We're going to be working through this exercise 2B from C1. Okay. Okay, now, in order for us to understand surds, we only need to understand square numbers. That's what square numbers are all about. So this is our introductory. Okay. Surds are all about square numbers. Right, let's give me, okay, someone just give me the first 5 square numbers, please. We have 1 times by 1, which is?
1.
Which is a bit of a useless number actually. The next one is 2 times by 2.
9.
Okay, yeah, and then we have 9, and then 16, 25. Okay,
36.
Nika, 36,
49.
49. Okay, Samia, the next one please.
64.
And one more.
81.
Okay. Right. You need to make friends with these numbers here. Okay, 1. Actually, 1 is a bit of a, yeah. You don't need to worry about 1. Starting from 4. 4, 9, 16, 25, 36, 49, 64, 81. You need to memorize them. Okay? You need to memorize these numbers, and we'll be needing them throughout the exercise. Okay. You can check if you can copy on that. Okay, right. Now, let's have a look at some of the basic rules of what we can and cannot do with surds. So all surds rely on you knowing these square numbers. Okay, so now, okay, if you have a product in a surd, you can split it up into its component factors. So if you have a number that's made up of A times by B, it can be rewritten as the square root of A times by the square root of B. These are some of the rules we are allowed to do with the square root. Okay, now, if you have in your square root sign, you have A add B, you can't do anything to that. That is not equal to the root of A plus the root of B. So, this we can do, and that we cannot do. That's not allowed. So the same way we think, oh yeah, we can split them up. Can I split these up? No, I can't. But there's an add or a minus. So if we have okay, so again, that one. So we can do that. We can't do these ones. Okay. The next one. Okay, what happens when we have a quotient, a division? Can we split those up? Yes, we can. We can't split the divisions. So that's allowed. Okay, can you please copy these down in your books as you're going along? Someone will be rubbing off the board soon. So I'm going to circle the ones that we can do. This is the basic rule. All surds rely on you being able to identify square number factors within a number. Square number factors. So that's what we've written down, the square number factors which are important to us. Okay, we can add another one onto there. So these all the square numbers are important. Next, these are the rules of simplifying that we are allowed to do. If you have a number, when you split a number into its product, we can split that product up separately. If you have a number that involves a quotient, a division calculation, then we can split up that division calculation into two separate surds as well. Okay, ladies, are we happy with that first of all? Okay, with that basic stuff. Right. Let's start looking at a question. And also, one other thing. We need to know our square numbers and how many of us are familiar with prime factorization? Okay. Doing prime factorization, splitting a number into its prime factors. So we need to know this first of all. We need to know what the rules are. And the third item, which I'm going to squeeze over here. Hopefully the video will pick that up. Okay. You need to be able to do prime. Split a number into its prime factors. You need to know what square numbers are, what you can do, and prime factors. Okay. Should we just do a quick example? Okay. If the number 112, you have to divide it into its prime factors. Now, in order to divide into prime factors, we need to know what the first couple of prime numbers are. So this, please why we say, don't say 1. Okay. What is the first prime factor, prime number, sorry, that we can have? 2. Excellent. I'm just writing them on the side over here, because I'm only out of board space. 2. Okay, give me the next 2.
3.
2, 3, 5. Excellent. Okay, Nika, can you give me the next 2 prime numbers?
7 and 11.
Okay, and I think really that's as much as we can actually be using in these kind of questions. We might actually go on to 13. There's normally the first couple of prime numbers that we're going to be using. This question here is actually going to be our first question that we're going to be doing. Anyway, prime factors. But actually I think we should just do an easy one. A different one. So if we have to split up 60 into prime factors, the method that I would like you to use, you might have a different way. Use 3 methods. The method we use is the bus stop method, upside down. We start dividing 60 by any one of these in any order, it doesn't make any difference. But I normally like to start with the 2 and move on to the 3s and the 5s and stuff. So the 60 divided by this prime number, and the answer is yes. 60 will divide by 2. So we do 60 divided by 2. Now 60 divided by 2 will give us 30. Okay? 60 divided by 2 will give us 30. Okay, and then we have 39, we have to divide that by a number. What should we divide? Can we divide that by 2 as well? Okay, 2. And 30 divided by 2 will give us 15. Now, we can't divide 15 by 2. We go to the next prime number, which is 3. So 15 divided by 3 will give us an answer of 5. Now, 5 won't divide by 3. 5 will divide by Samia 5. And that gives you 1. So 60 is equal to 2 times by 2 times by 3 times by 5. Simplifying surds and working with surds relies on you being able to do this for each of the numbers. Okay, or for most of them being able to split it up and look at where the factors are. Now, if we look, so we have these numbers over here. Can you see the square numbers already in the answer? It won't be actually that visible, but there's square numbers in the answer. Can you see square numbers? Where are the square numbers?
2 times
2 times by 2. So we've actually we've got a square number here, which I'm going to put a square on. And rewrite it as 4 times by 3 times by 5. Okay. Alright. There's the square number. So the skills we need to understand surds is recognizing our square numbers, recognizing the rules of what we like to do, and being able to do prime factorization. That is the very, very basics, and this is what we need to be experts at. Skill number 1, square numbers, what we can do, and what we can't do, and being able to do prime factorization. If you know these and you can do these 3, doing surds should be quite straightforward. It's only because we miss out these elements that when we try doing surds we can't do it. Okay. Right. Okay. Sorry, the 6 has gone off the bottom of the video. Okay, right. Are you happy with all this? I can add all this stuff off. And then we're going to move on to, well, we haven't got much board space left. Actually, let's try to get one question on this side. Okay, let's do our first question. Actually, just leave that on the board. Right, just make it read out the first question to me, please, on exercise. Right, this is the exercise that we're going to be doing today. So for those of you who want to follow us at home, them are the questions. Then you can pause and copy them out. Okay. It's all in the simplifying. If you can simplify surds, you can do any part of surds. Say simplify the root of 112. So we actually start with the third part first, looking at the prime factors, and we'll work around those key steps. So we've got the prime factors written down there, which is going to be 2, 3, 5. Okay, now 112. What do we know definitely divide by, Anika? 2. So we are now going to start dividing 112 by a prime factor, prime number. 112 divided by 2 will give us 56. Okay, can I still divide that by 2, Smia? Yes. And that will give us what? Half of 50 is 25, half of the 6 is 3, 20. Okay, divide that by 2 again, and what do we get? 14. 14, will that divide by 2? Yeah? Right, so now we have 7. We need to divide that by 7. So let's rewrite the. So we have now 112 is equal to 2 times by 2 times by 2 times by 2 times by 7. Now, as we look at these numbers over here, it doesn't look like there are any square numbers in there, but the square numbers are actually in there. Okay, right. Anika, can you see the first square number? First square number is there. Put a square around it. Second square number, Sundas?
Okay.
Okay. go through what we just done. We have to simplify the root, the surd, which is working out the surd, which is square root of 112. Okay. Now surds, when we give complex surds, they are normally referring to irrational numbers, numbers that won't turn into whole numbers normally. So within the number 112, we are now going to work out all the prime factors in order to identify the square numbers, what square numbers are in this number. Because the number 112 is quite big, so we might not be able to see straight away what the square numbers are. So, as we divided by 2, we got this number divided by 2. So this procedure here, you're all familiar with prime factorization. Then we end up, keep on dividing until we end up with 2 times by 2, times by 2, times by 2, times by 7. So this part here will give us a first square number, that's another square number, and I'll put boxes around them. Now what we're going to do, we're going to put these back into there. Okay? So we say the square root of 112 is equivalent to okay. At the moment I'm emphasizing the squares. You can put the squares into your work as well. The squares are there just to identify that I've found a square number. You'll see how important those are now. Now, you split the 112 into 3 factors, 2 square numbers and we have a prime number as well in there. What do we do now, Anika, to this big surd equation, this big surd here? What do we do to it? We follow which rule? Step 2, we just split them up into its factors. Okay, let's do that then. Okay, now we split them up into the separate elements. That's separate, and that's separate. Now we've identified square numbers. Can we square root a square number? Of course. So square rooting a square number. So square root of 4 will give us what answer? 2. And the square root of 4 is going to give us another 2. Samia, look over here. Okay, no over there. Square root of 7. What's square root of 7 going to simplify to, Samia?
Just 7.
No, square root of 7. Stay as it is. Okay, we're nearly there now. Nearly there. So, what do we do with the 2 times by 2 times by that? How do we simplify? We're nearly finished now. Anika, what do we do with those? How do we tidy this part over here?
2 times 2, which is 4, and then you times it by 7, so you do 4 square root of 7.
Lovely, beautiful answer. Okay, can we see that bottom part of the answer? Can you see this part?
Yeah.
Okay, 2 times by 2 is 4. Is that in there? Okay, lovely. Alright, let's move out the way. You just hear me now. Okay, Santos, have you got that down? If you haven't, please get it down. So there's our question, and here's the answer. So the root of 112 simplifies down in this topic of surds to 4 root 7. So before we can do any of these questions, we need to understand square numbers. Actually, that's probably the next thing. Prime factors, I've labeled 2 and 3 is making difference. So you need to understand how to prime factorize, and you need to understand what we're allowed to do. Once you understand these 3 elements, we've used all those 3 elements here. If you need to go through this question again, please just pause the video and rewind the bar when you're looking at this video later on YouTube. Okay, are we happy with that, ladies? Is that good? Now, we're going to give you a couple of questions to do. I think we've done a multiplying one, we've done a one that you split that up. Should we do one division question? Let's do one division question. Let's see how we get on with that. Okay. Okay, let's get this one stressed away. Great. Okay. Right. You need that question up there? That question can be called example number 2. Example number 2. Okay. Example number 2, we have the square root of 63 over 3. In this case here, the square root sign is not extending over both parts. It's just a division question. So we'll have top part and the bottom part. Actually, this question here, you might actually take it that way. Now, root 63. What numbers are inside 63? 63 is quite a nice number. What numbers inside 63? What factors could you split up with you thinking about square numbers?
7 and 9.
7 and 9. Thank you, Anika. So in this question here, we don't actually need to do this long method here because the number is familiar to us. It's a number that's within our times tables. This number is not in our times table, so we need to, for that reason, we need to do this longer method. Okay. Yeah. What's on that side? What's looking over there? Okay. So things we need to count on this side as well. Okay, we just have to change our position in the classroom. So root 63 over 3, so we have 9 times by 7 divided by 3. Now, so around the 9, okay, alright, just have to look this way, folks, because the camera's moving a bit. Okay, so we have 9, root 9, I put a square on the root 9, because that's a square, the number 9 is a square number. Okay, put the square root sign back on. Okay, now, let's follow one of the first steps we said. If we have a square root, okay, with a product in there, we can split it up. Okay, which we've done so far. Now root 9 again, emphasizing the squareness of it. 9 is a square number. That's very, very important. Now what is the root of 9? I'm going to run out of board space. Crash. The root of 9 is equal to?
3.
So 3 times by root 7 divided by 3. The root 9 becomes 3. Times by root 7 gets copied across, 3 gets copied across. Now, what can we do here? Now, that question is a product. The bottom, altogether this makes a quotient division question. What can we do with these 3's?
Cancel them.
We can cancel them. If there was a plus there, could you cancel it then?
No.
Minus? No, you can't do that. So only if it's a product you can do it. So because we got times here, we can now cancel across. So divide this by 3 gives you 1. Divide this by 3 gives you 1. So we're left with 1 times by root 7 is root 7, and divided by 1 is still root 7. So that's the final answer for that one. folks. Thank you. Just come in. You can put some grab all the papers in front of you and move them. There's 6 of them small behind you onto the table. Leave them there. Table. Okay, sorry for this bit of a see back for the camera. We're just rearranging the position of the webcam for the recording, so apologies please, all you YouTube viewers. Alright. That looks much better. Let's get the eye of the ground in. Okay. Well, that's a reflection. Okay. So let's do another question. So this one doesn't involve the quotient part, but this one's a nice straightforward one. So we got the square root of 25 divided by 9. So now 25 straight away is a square number. Okay, and then we have the number 9. They're both square numbers. Now, what we're going to do, what we said earlier, we can split this up, this quotient, into 2 separate sets. Okay, the square root of 25 will give us a nice and straightforward 5. The square root of 9 will give us a nice forward 3. So at the moment the fraction has been left in a top heavy form. So Nika, how would I finish this question off? So 5/3.
1 2/3.
5 divided by 3 is 1, remainder 2, 1 and 2/3. Well done Nika, thank you very much. Okay. So we done question, just a number on its own, prime factorization, identifying the square numbers, splitting up the square root, and then square rooting. This question here was a quotient question. The top question went along the top, the bottom went along the bottom, then we cancel the end. Here we have a quotient inside a third question, so then we split them up into square numbers. -5/3 equals 1 and 2/3. Okay. Are we happy with those examples? Right. Okay. One further example. Okay, now. I'm still looking over there. Okay, we're just doing a bit more rearranging of the students. Just give us a moment. Musical chairs. Okay, next question, we'll just quickly get started. The next question involves the product in the first place. So the root of 12. That's it. You'll be famous forever. Okay, I'm just going to pass the chair over. Okay. Push. Okay. Sit up. That's better. Okay. So root 12 times by root 21. This question here, we already started off with a question that are split. It's got 2 surds in it. So you're thinking, how do I do this question? You do it the same, you just do it as 2 mini questions. Do this as 1 question, do that as another question. Now, think about, when you look at a number, you should be thinking square numbers. What square numbers does this number contain? So the number 12, does it contain square numbers? Sundars. Think, factorize the number in your head. It contains what? 4 and?
3.
4 and 3. Put 4 in that colour. And put 3 back into Okay. And then next we have root 21. Okay. So me, is root 21 containing square numbers? Yes or no?
No.
No. Okay, so that one, what can we split up into?
3 times 7.
Okay. You might think, why have I split into numbers that are not square numbers? But they will help us in a bit, you'll see. Because we got a 3 there and a 3 here. Now, we have this third over here. Root 12 becomes 4 times by 3. 21 becomes 3 times by 7. Now let's split them up individually. So we should have now 4. Keep that square number. 2 by 3. Oops. Let's come inside. Okay. We can either do it like this first, split them all up and then put the sides on them, or we can actually, in the first step straight away, absorb them all into one. Okay, so what happens when you multiply a third by itself? What's root 3 times by root 3? That can be now reinterpreted. Any third multiplied by itself gives you what?
3.
Gives you the number inside, 3. So we left with now root 4. Root 4 gives you 2. Root 3 times by root 3 will give you 3. Times by 7. Okay, and now we simplify this. 2 times by 3 will give you
6.
Okay. What I would like to do now is do the same question again, but in a slightly more efficient way to find that. Okay, let's move over to this side here. So that's root 12 by root 21. Okay, for this question here, okay, now, do you remember in the first part we said when you have a third as a product, we can split into 2 parts. Can we do the opposite? Can we get 2 parts put into 1 part? Yes. We can do the opposite as well. So we have 1 third times by another third. Can we put them back together under one thing? Of course we can. That's the other way I want to show you doing this question in a more efficient way. So what we do now, we collapse the 2 individual root signs into one. We're using the rule that we did in the beginning of the lesson in reverse. So the rule works both ways. Now, we're in a better situation now. So 12 is made up of 4 times by 3. 21 is made up of 3 times by 7. So let's start identifying the square numbers. Here's my first square number. And here's my second square number. It looks like a bit of a rectangle, but I'm sorry about that. Alright. Okay. I'm just going to finish this question, then I'm going to do something about the reflection on the board. Okay, the black pen. Okay, ladies, are you happy with what we've done so far? Okay, we absorb this back onto one big one. We now factorizing, taking consideration we want to take square numbers out. And look what we've got here. One of the numbers which wasn't a square here and wasn't a square here has now become a square. Has now become a square because they got together. 3 times by 3 is a square number. So now we're going to split these up again. Put them together, split them back up again. Okay, I'm continuously doing these squares around here. This is just for the emphasis while you're learning for the first time, so you can be identified. I've got a square number here. This is a square number here. We need these numbers. Now, What we need to do next is actually square root them. So Samia, square root of 4 is 2. Okay, Nika, square root of 9 is 3. And what do we do with the root 7?
Stays the same.
Root 7 stays the same. So we have 2 times by 3, which is
6.
so we get exactly the same answer as that. But I feel with this one here we got a bit more of the, it's more of a clearer technique. So that method is good as well. But I myself personally prefer to do the question, think about the question in this way. Bring the two surds back together, factorize the numbers, identify the square numbers, then split it back up again. Okay, right, that's going to actually be the end of the first clip of this introduction. Okay, so we're going to stop the video now and the students are going to do some questions and then we're going to come back into part 2 of the video. Okay, right ladies, I want you now to do exercise 2B. Nika, have you done the even numbers? Questions?
I've done like 1, 2, 3, 4, 5, 6.
Okay, you do the ones you haven't done yet.
Okay.
And Sundars and everybody, and Smia, can you do please the odd numbered questions in exercise 2B? Right. Okay folks, please join us back again in part 2 of this video. Thank you for watching. There's too much reflection. Where's the reflection coming from?